Hello and welcome. I'm glad you found your way here tonight. Perhaps the day was long, or perhaps you're simply someone who prefers falling asleep to gentle ideas rather than silence. Either way, this space is for you now. There is nothing you need to do. No task waiting, no thought requiring attention. Just let yourself settle into wherever you are. Let your breathing find its own pace. Let the weight of the day begin to lift, slowly, like mist rising from still water at dawn. Tonight, we're going to wander together through something vast and beautiful. We're going to explore our home galaxy, the Milky Way, through 100 quiet facts. Not in any hurry. Not toward any destination. Just drifting from one idea to the next, the way starlight drifts across centuries of space before reaching our eyes. Some of what you hear may surprise you. Some may feel familiar. All of it is offered gently, like stones placed along a path you can follow as far as you wish before sleep carries you elsewhere. So let's begin. The Milky Way is not a single thing but a gathering. It is a collection of hundreds of billions of stars held together by gravity, each one a sun in its own right. Some are larger than our own sun, some smaller, some brighter, some so dim they barely register against the dark. They do not touch. They are separated by distances so vast that light itself takes years to cross from one to the next. And yet they belong to the same structure, the same slow spiral turning through the universe. A family of fires spread across the cold. When we say hundreds of billions, the number becomes almost meaningless. It is too large to picture, too vast to hold in the mind. But consider this. If you counted one star per second, without stopping, without sleeping, it would take you thousands of years to count them all. And still you would not be finished. The galaxy contains more stars than there are grains of sand on many beaches, more stars than there are seconds in a human lifetime multiplied many times over. Each one is a furnace of nuclear fire, burning hydrogen into helium, light into warmth, fuel into time. If you could see the Milky Way from outside, from some impossible distance, it would appear as a flat disk with a bright central bulge. Spiral arms would curl outward from the center, wrapped in dust and gas and clusters of young stars. It would look almost like a cosmic pinwheel, though not a perfect one. There are warps and bends, asymmetries and ripples. It is not a geometric shape. It is a living structure, sculpted by gravity and time. The disk is not perfectly flat. It curves slightly, warped by the gravitational pull of satellite galaxies and the uneven distribution of dark matter. If you could view it edge-on, you would see this gentle wave, a ripple frozen in the act of passing through. The galaxy breathes, in a sense, flexing slowly over millions of years, responding to forces both visible and hidden. It is not rigid. It is supple, bending without breaking, maintaining its shape while constantly adjusting to the tugs and pulls of its environment. Our solar system sits within this disk, roughly 2/3 of the way out from the center. We are not at the edge, but we are far from the crowded core. From where we orbit, the galaxy stretches above and below us, a river of light visible on clear dark nights. That pale band across the sky is the accumulated glow of billions of stars too distant to see individually but bright enough together to form a softly luminous path. This position, far from the galactic center, may be fortunate. The inner regions of the galaxy are more turbulent, more crowded with stars, more prone to the violent events that can sterilize planets. Out here, in the relative calm of the galactic suburbs, the conditions have been stable enough for life to emerge and evolve over billions of years. We orbit in a quiet neighborhood, far from the busiest intersections, sheltered by distance from the most dramatic upheavals. The center of the galaxy lies in the direction of the constellation Sagittarius. If you were to look that way on a summer night from the northern hemisphere, you would be gazing toward the densest concentration of stars in our galactic home. You cannot see the true center with your eyes. Dust clouds block the view, absorbing visible light. But behind that veil, something immense waits in the dark. A gravitational anchor around which everything else turns. The dust that blocks our view is not empty or inert. It is composed of tiny grains, each smaller than a grain of sand, made of carbon and silicon and ice. These grains drift through space, absorbing starlight and re-emitting it as infrared radiation. They are the raw material of planets, the building blocks of worlds. The same dust that hides the galactic center from our eyes may one day become part of a new solar system, a new Earth, a new life form wondering about its origins. At the very heart of the Milky Way sits a supermassive black hole. It is called Sagittarius A star, and it contains the mass of roughly 4 million suns compressed into a region smaller than the orbit of Mercury. Nothing that crosses its boundary escapes. Not matter, not light, not time as we understand it. And yet this black hole does not devour everything around it. Most stars orbit at safe distances, circling the center in long, patient loops. The black hole is less a monster and more a silent anchor, holding the galaxy's inner structure in place. We cannot see the black hole directly, but we can see its effects. Stars near the galactic center move in ways that reveal the presence of something massive and invisible. They whip around at tremendous speeds, tracing elliptical paths that can only be explained by an enormous concentration of mass in a very small space. Some of these stars have been tracked for decades, their orbits mapped with increasing precision. They are cosmic witnesses, testifying through their motion to the presence of something we cannot otherwise detect. Stars near the galactic center move faster than those farther out. The gravitational pull there is stronger, and so stars whip through their orbits in just a few million years. Our Sun, by contrast, takes roughly 230 million years to complete a single orbit around the galaxy. This is called a galactic year, a span of time so long that dinosaurs had not yet appeared when the Sun last occupied this position in space. We are deep in one orbit, halfway through perhaps, with countless more to come. A galactic year is a humbling measure of time. In a single galactic year, entire species evolve and go extinct. Continents drift and collide. Ice ages come and go. The whole of human history, from the first cave paintings to the present day, occupies only a tiny fraction of a single galactic year. The Sun has completed perhaps 20 orbits since it formed. In cosmic terms, our star is young, barely past childhood, with most of its life still ahead. The Milky Way is ancient. Current estimates place its age at around 13 billion years, nearly as old as the universe itself. In those early eons, it did not look like it does today. There was no disk, no spiral arms, no orderly structure. Just clouds of gas and dark matter beginning to collapse under gravity, forming the first stars and the first rough shapes of what would one day become our galaxy. Those early stars burned hot and brief. Many exploded, scattering heavy elements into space. From their remains, new stars formed. And so the cycle began. The first stars were different from those we see today. They were made almost entirely of hydrogen and helium, the elements created in the Big Bang. Without heavier elements to help cool the collapsing gas, these stars grew enormous, perhaps hundreds of times more massive than the Sun. They burned through their fuel quickly, living only a few million years before exploding. Their deaths seeded the universe with the first heavy elements, the carbon and oxygen and iron that would eventually become planets and people. Most of the stars you see in the night sky are relatively young, at least in cosmic terms. They formed within the last few billion years, part of the ongoing process of stellar birth that continues even now. But scattered through the galaxy are older stars, ancient survivors from earlier epochs. Some of these predate the formation of the disk itself. They drift through the halo, the sparse outer region of the galaxy, following orbits that take them far above and below the plane where most stars reside. These ancient stars are like elders in a city, carrying memories of times before the current order was established. Their chemical composition reveals their age. They contain fewer heavy elements than younger stars, because they formed before many generations of stellar death had enriched the galaxy with metals. By studying these old stars, astronomers can piece together the history of the Milky Way, tracing its evolution from a chaotic cloud to the structured spiral we inhabit today. The halo is not empty. It contains old stars, globular clusters, and vast amounts of dark matter. Globular clusters are tight spheres of stars, sometimes containing hundreds of thousands of suns bound together by mutual gravity. Many of these clusters are among the oldest objects in the galaxy. Their stars formed before the Milky Way had settled into its current shape. They orbit the galactic center on elongated paths, dipping in toward the core and then swinging far out into the darkness. Globular clusters are beautiful and strange. Imagine a ball of stars so dense that near the center, They are packed 1,000 times more closely than in our neighborhood of the galaxy. The night sky from a planet in such a cluster would be dazzling, filled with brilliant points of light in every direction. There would be no true darkness, no quiet corners of sky. Just stars upon stars, a dome of fire that never dims. Dark matter makes up most of the galaxy's mass, yet it cannot be seen. It does not emit light. It does not absorb it. It does not interact with ordinary matter except through gravity. We know it exists because without it, the galaxy would not hold together. Stars at the outer edges orbit too fast for the visible matter alone to keep them bound. Something unseen provides the extra gravitational pull. Dark matter is the invisible architecture of the Milky Way, shaping its structure from the shadows. The nature of dark matter remains one of the great mysteries of physics. We know what it does, but we do not know what it is. It is not made of atoms or molecules. It does not reflect or emit any form of electromagnetic radiation. It passes through ordinary matter like a ghost through a wall. Experiments around the world are searching for dark matter particles, trying to detect the faint signal of their rare interactions with normal matter. So far, the particles have eluded capture. The galaxy keeps its secrets well. The visible part of the galaxy, the disk and bulge and spiral arms, accounts for only a fraction of its total mass. The rest lies in the halo, mostly as dark matter, extending far beyond the furthest stars. If the Milky Way were a city, the bright disk would be the downtown core, glittering and dense. The halo would be the vast suburbs and countryside stretching outward, quiet and sparse but far larger in total area. This means that most of the galaxy is invisible. The stars and gas and dust that we can observe are like the lit windows of buildings at night. They reveal the presence of structure, but they do not show the whole. The dark matter halo extends much farther than the visible disk, wrapping around the galaxy like an enormous invisible sphere. We are embedded in it, surrounded by it, held by it, and yet we cannot see it. Light takes a long time to cross the galaxy. From one edge of the disk to the other is roughly 100,000 light-years. That means light leaving a star on the far side of the galaxy right now will not reach Earth for 100,000 years. When you look at the night sky, you are seeing the past. Each star's light carries news from years, decades, centuries, or millennia ago. The deeper you look, the further back in time you see. This is a strange and wonderful feature of the universe. Because light travels at a finite speed, and because cosmic distances are so vast, we are always looking into the past. The sun we see is the sun as it was 8 minutes ago. The nearest stars are years in the past. The nearest galaxies are millions of years old by the time their light reaches us. We cannot see the present. We can only see history, unfolding in layers around us like the rings of an ancient tree. The stars are not fixed. They are all in motion, orbiting the galactic center, drifting relative to one another, pulled and nudged by gravitational interactions. The constellations you see tonight are temporary arrangements. Over tens of thousands of years they will shift and change. Stars that appear close together may actually be separated by vast distances, their apparent proximity an illusion of perspective. The night sky is a snapshot of a moment in a very long story. If you could watch the sky and fast forward, sped up by a factor of millions, you would see the stars swirl and scatter like leaves in a slow wind. The familiar patterns would dissolve. New patterns would form and dissolve in turn. The sky would become a river of light, flowing around the galactic center, each star tracing its own path through the current. Nothing would stay still. Nothing would remain the same. Some stars travel alone. Others belong to pairs or groups, orbiting each other as they orbit the galaxy. Binary stars are common, two suns circling a shared center of gravity. Some binaries are so close they nearly touch, exchanging material in streams of superheated gas. Others are separated by distances so great that their orbits take thousands of years to complete. A few stars belong to triple or quadruple systems, complex gravitational dances that can remain stable for billions of years. Binary stars offer a window into stellar physics. By studying how two stars orbit each other, astronomers can measure their masses with precision. This is much harder for a single star, which offers no convenient partner to trace its gravitational pull. Binaries also produce some of the most dramatic events in the galaxy, including certain types of supernovae, where one star steals material from its companion until it crosses a critical threshold and explodes. Stars are born in clouds of gas and dust called nebulae. These clouds drift through the galaxy, vast and cold, composed mostly of hydrogen. When something disturbs a cloud, perhaps a passing shock wave or the gravity of a nearby star, regions within it can begin to collapse. As the gas falls inward, it heats up. Pressure builds. Eventually, the core becomes hot and dense enough for nuclear fusion to ignite. A new star is born, glowing with the energy of hydrogen atoms fusing into helium. The moment of ignition is called the zero-age main sequence, the point at which a star begins its true life as a hydrogen-burning furnace. Before this, the collapsing cloud is called a protostar, a warm and growing ball of gas not yet capable of sustaining fusion. The transition from protostar to star can take millions of years for the smallest stars, or just a few 100,000 years for the most massive. Time moves differently for objects of different sizes, even in the process of being born. The process of star formation is not gentle. It is turbulent and chaotic, with gas swirling and colliding, magnetic fields tangling, and radiation pouring outward from the newborn star. Often, multiple stars form from the same cloud, emerging as siblings from the same cosmic womb. These stellar nurseries are some of the most visually striking regions of the galaxy, glowing with the light of young stars and sculpted by their radiation into pillars and arcs of illuminated gas. The images from these regions are among the most famous in astronomy. Great columns of gas rise against backgrounds of blazing light. Shock waves carve cavities in the clouds. Jets of material shoot outward from newborn stars, sometimes stretching for light years before dissipating into the surrounding medium. These scenes of creation are violent and beautiful, chaotic and productive. From destruction comes new life. From collapse comes light. Not all gas becomes stars. Much of it remains diffuse, spread thinly through the spaces between stars. This is the interstellar medium, a sparse sea of atoms and molecules that fills the galaxy like a faint mist. It is not uniform. Some regions are denser, some thinner. Some are hot, ionized by stellar radiation. Others are cold, dark, and molecular. The interstellar medium is the raw material from which stars are made and to which they return when they die. The interstellar medium is often invisible to optical telescopes, but it reveals itself in other wavelengths. Radio telescopes can detect the faint emission of hydrogen atoms. Infrared telescopes can see through dust that blocks visible light. X-ray telescopes can map the hot gas heated by supernova explosions. Each wavelength reveals a different aspect of the medium, a different layer of the galaxy's invisible skin. When a star exhausts its fuel, its fate depends on its mass. Small stars like our Sun will swell into red giants, shedding their outer layers into space before collapsing into dense, cooling remnants called white dwarfs. These remnants are no larger than Earth but contain the mass of a star, packed so tightly that a teaspoon of their material would weigh tons. White dwarfs glow faintly with residual heat, fading over billions of years into cold, dark cinders. The transformation from a living star to a white dwarf is gradual and beautiful. As the star swells into a red giant, it sheds layers of gas that drift outward, forming shells and rings of glowing material. These are called planetary nebulae, though they have nothing to do with planets. They are the breath of a dying star, expanding into space, enriching the interstellar medium with elements that will eventually become part of new stars and worlds. More massive stars meet more dramatic ends. When they exhaust their fuel, their cores collapse suddenly, triggering an explosion called a supernova. For a brief moment, a single dying star can outshine an entire galaxy. The explosion scatters heavy elements into space, elements forged in the star's core during its lifetime and in the violence of its death. These elements, iron and gold and carbon and oxygen, mix with the interstellar medium and eventually become part of new stars, new planets, new life. A supernova is one of the most energetic events in the universe. In a matter of seconds, more energy is released than the sun will produce in its entire lifetime. The shock wave expands at thousands of kilometers per second, sweeping up gas and dust, compressing it, triggering new rounds of star formation. The death of one star can be the birth of many others. The galaxy cycles through generations, each one building on the last. The heaviest elements are not made in ordinary stars. They require the most extreme conditions, the collision of neutron stars, the deaths of the most massive suns. When two neutron stars spiral together and merge, they release a burst of energy and forge elements heavier than iron in quantities that ordinary stellar processes cannot match. Gold, platinum, uranium, these atoms trace their origins to such cataclysms. The jewelry we wear, the elements in our technology, were born in cosmic violence billions of years ago. These collisions are rare, happening perhaps once every 100,000 years in a galaxy like ours. But over billions of years they add up. The gold in your ring, the platinum in your electronics, the uranium that powers nuclear reactors, all of it was forged in moments of unimaginable violence, then scattered through space, then gathered into the cloud that became our solar system. You were the remnants of ancient catastrophes, transformed into beauty and utility. Neutron stars are the collapsed cores of massive stars that exploded as supernovae. They are incredibly dense, containing more mass than the sun squeezed into a sphere only a few kilometers across. Their gravity is so strong that their surfaces curve space noticeably. Some neutron stars spin rapidly, emitting beams of radiation that sweep across space like lighthouse beams. When these beams cross Earth's line of sight, we detect them as pulsars, regular flashes of radio waves ticking with remarkable precision. Pulsars are among the most precise clocks in the universe. Their rotation rates are so stable that they rival atomic clocks in accuracy. Astronomers use pulsars to test theories of gravity, to search for gravitational waves, to probe the interstellar medium. They are tiny, fast, and useful far beyond their modest size. A neutron star is a city-sized ball of matter denser than an atomic nucleus, spinning sometimes hundreds of times per second, broadcasting its presence across the galaxy. Black holes are even stranger. When the most massive stars collapse, no force can halt the implosion. The core crushes down to a point of infinite density, a singularity, surrounded by a boundary called the event horizon. Anything that crosses the event horizon is lost to the outside universe. Black holes do not emit light, but they can be detected by their effects on nearby matter. Gas falling toward a black hole heats up and glows brightly, sometimes outshining entire galaxies before vanishing beyond the horizon. The event horizon is not a physical surface. It is a boundary in space, the point of no return. Cross it, and no amount of energy can carry you back. From outside, you would see objects falling toward the black hole slow down and dim as they approach the horizon, their light stretched into longer and longer wavelengths by gravity. From the perspective of the falling object, however, the crossing would be swift, perhaps even unnoticed, until the tidal forces began to tear them apart. The supermassive black hole at the center of the Milky Way is not the only black hole in the galaxy. Astronomers estimate that there may be millions of stellar mass black holes scattered throughout the disk, the remnants of massive stars that ended their lives in collapse. Most of these are invisible, drifting silently through space. A few reveal themselves when they pass close to other stars or when they consume material that heats up and radiates before falling in. These stellar black holes are ghosts of dead stars, wandering the galaxy in darkness. Occasionally, one passes close enough to a companion star to draw material from it, creating a temporary accretion disk that glows in X-rays. These X-ray binaries are some of the brightest sources in the X-ray sky, beacons that mark the locations of black holes feeding on their companions. But most black holes drift alone, dark and silent, their presence known only through their gravity. The galaxy is full of things we cannot see. Dark matter, black holes, cold gas clouds, dim brown dwarfs that never achieve true starhood. What we observe directly is only a fraction of what exists. The visible stars are the bright surface of a much deeper ocean. Beneath that surface, in radio waves and infrared light and gravitational effects, lies a richer, more complex structure than the eye alone can perceive. This invisibility is not a failure of observation. It is a feature of the universe. Most matter does not interact with light. Most of the cosmos is dark, not because it is empty, but because it is filled with things that do not shine. Our eyes evolved to detect a narrow range of wavelengths, useful for navigating the surface of a planet but inadequate for perceiving the full complexity of the universe. We are learning to see with new eyes, instruments that extend our vision into realms we could not otherwise perceive. Brown dwarfs are objects that formed like stars but never gathered enough mass to ignite hydrogen fusion in their cores. They are too large to be planets, too small to be stars. They glow faintly with the heat of their formation and with the fusion of deuterium, a heavier form of hydrogen, but they are dim and difficult to detect. There may be billions of brown dwarfs in the Milky Way, filling the gap between the smallest stars and the largest planets. Brown dwarfs occupy a strange middle ground. They are not quite stars, not quite planets, but something in between. Some have been found with their own planets orbiting them, tiny systems built around failed suns. Others drift alone through the galaxy, cooling slowly over billions of years. They are the Alcerans of stellar formation, objects that almost made it but fell just short. And yet they are fascinating in their own right, windows into the physics of objects too hot to be planets and too cold to be stars. Planets are common throughout the galaxy. Every star you see likely has worlds orbiting it, some rocky like Earth, some gaseous like Jupiter, some frozen, some scorched, some perhaps harboring conditions suitable for life. The Milky Way may contain more planets than stars. Trillions of worlds, each with its own composition, its own orbit, its own story. Most we will never see. But their existence transforms our understanding of the galaxy from a collection of suns to a vast archipelago of worlds. The discovery that planets are common has transformed astronomy. For most of human history, we knew of only the planets in our own solar system. Now we know of thousands of others, with more being discovered all the time. Some orbit their stars in just a few days, so close they are heated to thousands of degrees. Others orbit so far out that they take centuries to complete a single year. Some are rocky, some are gaseous, some are covered in oceans, some in ice. The diversity is staggering. Some planets do not orbit any star. These are rogue planets, worlds that were ejected from their original systems by gravitational interactions or that formed alone in interstellar space. They drift through the galaxy in darkness, warmed only by their internal heat. There may be billions of them, outnumbering the stars themselves. Cold, silent, alone, they wander the spaces between suns, carrying with them the possibility of moons, of subsurface oceans, of chemistry that we cannot yet imagine. Rogue planets challenge our assumptions about what a world needs to support interesting chemistry or even life. Without a star to warm them, they would seem utterly hostile. But some may retain enough internal heat to maintain liquid water beneath icy crusts. Some may have thick atmospheres that trap warmth. We simply do not know. The universe is full of possibilities we have not yet considered, and rogue planets remind us to keep our minds open. The distances between stars are almost impossible to grasp. The nearest star to the Sun, Proxima Centauri, is over 4 light-years away. That means light, traveling at 300,000 kilometers per second, takes more than 4 years to make the journey. A spacecraft traveling at current speeds would take tens of thousands of years to reach it. The stars appear close together in the sky, but the spaces between them are vast, silent, and cold. 4 light-years sounds manageable until you try to imagine crossing it. Light is the fastest thing in the universe, and it still takes 4 years. Radio signals travel at the same speed, so a message sent to Proxima Centauri would take 4 years to arrive and 4 more years for any reply. A conversation would take decades. Visiting in person with current technology is simply impossible. The stars are close in the sky but impossibly far in space. And yet the galaxy is not empty. The interstellar medium, thin as it is, fills the spaces between stars. Magnetic fields thread through the disk. Cosmic rays, high-energy particles accelerated by supernova explosions and other violent events, stream through space at nearly the speed of light. Gravitational waves, ripples in the fabric of space-time, pass through unseen, carrying news of distant collisions. The galaxy hums with energies and motions that we are only beginning to detect. The space between stars is not a vacuum in the perfect sense. It contains roughly 1 atom per cubic centimeter, a density so low that it makes the best laboratory vacuum seem crowded by comparison. But over light years, even this thin material adds up. It absorbs and scatters light. It interacts with cosmic rays. It carries magnetic fields. The interstellar medium is not nothing. It is a faint something spread thin across enormous distances, participating in the life of the galaxy. The spiral arms of the Milky Way are not permanent structures. They are density waves, regions of slightly higher concentration that move through the disk like ripples through water. Stars drift into these regions, linger for a while, and then drift out again. The arms appear fixed only because new stars are constantly entering them as old ones leave. It is a pattern maintained by motion, a shape that emerges from the collective behavior of billions of individual orbits. Think of a traffic jam on a highway. The cars move forward, but the jam itself stays in roughly the same place because new cars are always entering as old ones leave. The spiral arms work similarly. They are not made of the same stars over time. They are patterns through which stars pass. The arms are not objects. They are processes, waves of density rolling through the disk over millions of years. Star formation is more common in the spiral arms. The higher density of gas and dust there makes it easier for clouds to collapse into new stars. This is why the arms appear brighter than the spaces between them, lit up by young, hot, blue stars that burn intensely but briefly. These stars trace the arms like lights along a highway, illuminating the pattern even as they themselves are short-lived passengers passing through. The blue light of young stars is short-lived. Blue stars are massive and burn through their fuel quickly, lasting only a few million years before exploding as supernovae. The fact that we see blue stars tracing the spiral arms tells us that star formation is happening there now, or at least was happening there a few million years ago. The arms glow with youth, with energy, with the brief but brilliant lives of massive stars. The spaces between the arms are not dead. Older, cooler stars still populate these regions, and star formation continues at a lower rate. The galaxy structure is a matter of degree, not sharp boundaries. Everything blends into everything else. The arms fade into the interarm regions, the disk fades into the halo fades into intergalactic space. The Milky Way has no true edge, only a gradual thinning, a slow dissolution into the emptiness between galaxies. This gradual fading makes it difficult to define the size of the galaxy. Where does it end? The disk has a relatively clear boundary, but the halo extends much farther, fading into the surrounding space. Dark matter extends farther still. If you define the galaxy by its gravitational influence, it reaches out to touch its nearest neighbors. Everything is connected. Boundaries are a convenience, not a reality. The galaxy is surrounded by satellite galaxies. These are smaller collections of stars, some containing only a few million suns, that orbit the Milky Way like moons around a planet. The most famous are the Large and Small Magellanic Clouds, visible from the southern hemisphere as hazy patches of light. But there are dozens more, many so faint and diffuse that they were discovered only recently. Some of these satellites are being slowly torn apart by the Milky Way's gravity, their stars streaming into our galaxy. The Magellanic Clouds are visible to the naked eye from southern latitudes, two smudges of light that seem detached from the main band of the Milky Way. They are nearby as galaxies go, only about 160,000 light-years away. They are irregular in shape, lacking the neat spiral structure of our own galaxy. They are also being affected by the Milky Way's gravity, pulled and stretched as they orbit, leaving trails of gas behind them. Over billions of years, the Milky Way has absorbed many smaller galaxies. Their stars now mingle with our own, indistinguishable except by careful analysis of their motion and composition. These mergers have shaped the galaxy structure, adding stars to the halo, stirring the disk, and perhaps triggering bursts of star formation. The Milky Way we see today is a composite, built from the accumulated remnants of many smaller systems. This process of galactic cannibalism is ongoing. Right now, several small galaxies are being torn apart by our galaxy's gravity, their stars stretched into streams that arc across the sky. In billions of years, even the Magellanic Clouds may be absorbed, their stars becoming part of the Milky Way's halo. The galaxy grows by consuming its neighbors, a slow and patient accumulation that has been happening for most of cosmic history. Not all arrivals have been gentle. Some galaxies collided with the Milky Way in events that disrupted both structures, sending shock waves through the gas and scattering stars into new orbits. Evidence of these ancient collisions can be found in the motions of halo stars, in streams of debris that arc across the sky, in the chemical signatures of stars that formed under different conditions. The galaxy carries scars from its past, healed but not erased. The most significant of these collisions may have happened around 10 billion years ago, when a dwarf galaxy plunged into the early Milky Way and was completely absorbed. This event may have shaped the thick disk, scattered stars into the halo, and triggered a burst of star formation. We see its remnants today in the motions and compositions of ancient stars, a ghost galaxy whose body has been absorbed but whose traces remain. The future holds another collision. The Andromeda Galaxy, our nearest large neighbor, is moving toward the Milky Way at over 100 kilometers per second. In roughly 4 to 5 billion years, the two galaxies will meet. Stars will not collide, the distances are too great, but the structures will be transformed. Tidal forces will stretch and distort both galaxies. Gas will compress and trigger new star formation. Eventually, after billions of years of interaction, the two spirals will merge into a single larger galaxy. The collision with Andromeda will be spectacular but not violent, at least not on a stellar level. The spaces between stars are so vast that actual collisions will be extremely rare. Instead, the two galaxies will pass through each other, their stars mixing and mingling like two clouds of smoke. The gravitational interaction will distort both structures, pulling out long streamers of stars, compressing gas clouds and triggering waves of new star formation. This is not destruction. It is transformation. Galaxies merge and evolve, their identities blending into something new. The stars of the Milky Way will continue to shine. The Sun, if it still exists, will orbit a new galactic center. The night sky will look different, but there will still be a night sky. Change on cosmic scales is slow enough that life, if it persists, can adapt. The merger is not an ending. It is a becoming. The merged galaxy has already been given a name by some astronomers. They call it Milkdromeda, a blend of Milky Way and Andromeda. It will be a larger, more massive galaxy, perhaps elliptical in shape rather than spiral. The night sky from within it will be different, perhaps brighter, perhaps more uniform. But the stars will still shine, and whatever life exists then will have its own constellations, its own stories, its own sense of home. The Milky Way is part of a larger structure called the Local Group, a collection of more than 50 galaxies bound together by gravity. The Local Group spans roughly 10 million light-years and includes the Milky Way, Andromeda, and dozens of smaller galaxies. It is a modest cluster, neither particularly large nor particularly dense. But it is our cosmic neighborhood, the region of space where gravity connects us to our nearest galactic neighbors. The Local Group is itself part of a larger structure called the Virgo supercluster, and the Virgo supercluster is part of an even larger structure called Laniakea. These structures are vast, spanning hundreds of millions of light-years, containing thousands of galaxies. At these scales, the universe begins to look like a web, with filaments of galaxies strung between enormous voids of nearly empty space. We are embedded in this cosmic web, one small galaxy in a vast and intricate pattern. Beyond the Local Group lie other groups and clusters of galaxies, arranged in filaments and walls that stretch across the universe like a cosmic web. The spaces between these filaments are voids, vast regions of nearly empty space where galaxies are rare. The structure of the universe on the largest scales is not uniform. It is textured, shaped by the gravity of dark matter into a pattern that emerged in the first moments after the Big Bang and has been evolving ever since. The cosmic web is the largest structure in the universe. Its filaments are rivers of dark matter along which galaxies form and cluster. Its voids are deserts, regions where matter is thin and galaxies are few. The web is not static. It evolves over time, with galaxies flowing along filaments, merging at intersections and gradually clumping into ever larger structures. We are watching the universe assemble itself, slowly, over billions of years. Light from the most distant galaxies has traveled for billions of years to reach us. When we look at these galaxies, we see them as they were in the early universe, young and still forming. The light carries information about conditions long ago, about the rate of star formation, the distribution of matter, the expansion of space. Astronomy is a form of time travel. The further we look, the deeper into the past we see. The most distant galaxies we can observe formed just a few 100 million years after the Big Bang. They appear as faint smudges of light, barely resolved even by our best telescopes. But they contain clues to the early universe, to the conditions that gave rise to all the structure we see today. By studying them, we learn about our own origins, about the processes that eventually led to the Milky Way and the Sun and the Earth and us. The universe is expanding. Space itself is stretching, carrying galaxies apart from one another. The most distant galaxies are receding faster than the speed of light, not because they are moving through space that quickly, but because the space between us and them is growing. This expansion began with the Big Bang and continues today, accelerating under the influence of a mysterious force called dark energy. The fate of the universe depends on this expansion, on whether it will continue forever or eventually slow and reverse. Dark energy is even more mysterious than dark matter. We know it exists because the expansion of the universe is accelerating, which requires some form of energy pushing space apart. But we do not know what this energy is or where it comes from. It may be a property of space itself, a cosmological constant that pervades the universe. Or it may be something more exotic, a dynamic field that changes over time. The nature of dark energy remains one of the deepest questions in physics. But these are questions for another night. Tonight, we remain close to home within the gentle embrace of the Milky Way. Our galaxy, with all its stars and gas and dust and dark matter, is vast beyond imagining but small compared to the universe. It is one island of light in an ocean of darkness, one structure among billions. And yet it is ours. It is where we live, where our sun shines, where Earth orbits, where life emerged and wondered about the stars. Let us return our attention to the sun, the star at the center of our own small system. The sun is an ordinary star. This is not an insult. It means the sun is stable, long-lived, and typical of the most common type of star in the galaxy. It has been shining for nearly 5 billion years and will continue for another 5 billion before it swells into a red giant and eventually fades into a white dwarf. In cosmic terms, the sun is middle-aged halfway through its life, reliable and steady. The sun's stability has been essential for life on Earth. A star that varied wildly in brightness, or that burned through its fuel quickly, would not provide the steady environment that life requires. The sun's constancy has given Earth billions of years to develop complex life, time enough for evolution to explore countless forms, time enough for intelligence to emerge. We owe our existence to a star that is, in the best sense, ordinary. The sun's light takes about 8 minutes to reach Earth. This means we always see the sun as it was 8 minutes ago. If it suddenly went dark, we would not know for 8 minutes. This is a tiny delay compared to the years and centuries that separate us from other stars, but it reminds us that even the nearest light is old by the time it arrives. We live in a universe where the present is always unreachable, where everything we see has already happened. 8 minutes is short enough that it feels like the present. We do not notice the delay. But it is a reminder that light takes time to travel, that even the most immediate things are slightly in the past. When you see the sun rise, you are seeing where it was 8 minutes ago. When you feel its warmth, you are feeling energy released 8 minutes earlier. The present moment extends only as far as your own body. Beyond that, everything is history. Earth orbits the sun at an average distance of about 150 million kilometers. This distance, called an astronomical unit, is a convenient measure for describing the solar system. It places Earth in the habitable zone, the region around a star where temperatures allow liquid water to exist on a planet's surface. This zone varies depending on the star's brightness and heat. For the sun, Earth sits comfortably within it, neither too hot nor too cold. The habitable zone is sometimes called the Goldilocks zone, after the fairy tale character who preferred things that were just right. For life as we know it, liquid water is essential. Too close to the sun, water boils away. Too far, it freezes solid. Earth orbits in the narrow range where water can exist in all three phases, flowing as rivers, falling as rain, freezing as ice, evaporating into clouds. This simple chemical compound, made of hydrogen and oxygen, is the medium in which life operates. The habitable zone is not a guarantee of life. Many factors influence whether a planet can support life, including its atmosphere, its magnetic field, its geological activity, and countless other variables. But liquid water seems to be essential, at least for life as we know it. The presence of water on Earth, maintained over billions of years by a delicate balance of temperature and pressure, has made our planet a haven for biology in a universe that is mostly hostile to it. Mars lies at the outer edge of the Sun's habitable zone, and Venus lies at the inner edge. Both planets may have had liquid water in the past. Mars shows evidence of ancient rivers and lakes, now dry and frozen. Venus may have had oceans before a runaway greenhouse effect boiled them away. The habitable zone is not a guarantee of hospitality. It is only a possibility, a region where conditions might be right if other factors align. Life on Earth has existed for nearly 4 billion years. It began in the oceans, simple single-celled organisms that gradually evolved into the diversity we see today. For most of that history, life was microscopic. Complex multicellular life appeared only in the last 600 million years or so. Humans have existed for a tiny fraction of that time, a blink in the long history of life on this planet. And yet we have developed the ability to understand the universe, to trace our origins back to the stars. 4 billion years is almost unimaginably long. It is nearly a third of the age of the universe. In that time, life has transformed the Earth, filling the atmosphere with oxygen, covering the land with forests, populating the oceans with countless creatures. Life has survived asteroid impacts, ice ages, volcanic catastrophes, and mass extinctions. It has proven remarkably resilient, adapting to almost every environment the Earth has to offer. Every atom in your body was once part of a star. The hydrogen in your water came from the Big Bang. The carbon in your cells, the oxygen you breathe, the calcium in your bones, the iron in your blood, all of these were forged in the cores of stars that lived and died before the sun was born. You are, in a very real sense, made of star stuff. The galaxy is not just something you observe. It is something you are part of, something you are made from. This is not poetry. It is physics. The elements that make up living things are the same elements found throughout the galaxy, in gas clouds and planets and asteroids and comets. Life is not separate from the cosmos. It is an expression of it, a way for the universe to know itself. When you look at the stars, you are the universe looking back, matter contemplating its own origins, stardust wondering where it came from. The iron in your blood and the iron in a meteorite are the same iron, forged in the same types of stellar explosions, scattered through space, gathered into planets, and eventually incorporated into living things. There is no special ingredient that separates life from non-life. We are made of the same atoms as rocks and rivers and stars. What makes us different is not our composition but our organization, the way our atoms are arranged into the intricate patterns of cells and tissues and organs and minds. The night sky has inspired wonder for as long as humans have existed. Our ancestors saw patterns in the stars and told stories about them. They used the stars to navigate, to mark the seasons, to predict floods and harvests. The sky was a calendar, a compass, and a canvas for mythology. Different cultures saw different shapes, named different constellations, and interpreted the lights above according to their own traditions and needs. The stories our ancestors told about the stars reflect their values, their fears, their hopes. They saw gods and heroes, animals and monsters, in the patterns of light above them. They used the stars to understand their place in the world, to find meaning in the vastness, to feel connected to something greater than themselves. We still do the same, though our stories have changed. We now speak of galaxies and black holes instead of gods and heroes, but the impulse is the same. Modern astronomy has transformed our understanding of the night sky, but it has not diminished its beauty. We now know that the stars are suns, that the planets are worlds, that the faint band of the Milky Way is a galaxy containing billions of stars. This knowledge does not make the sky less wondrous. If anything, it deepens the wonder. The universe is far stranger and more vast than our ancestors imagined, and we are only beginning to explore it. Knowing that the stars are suns does not make them less beautiful. If anything, it makes them more so. Each point of light represents a furnace of nuclear fire, a potential solar system, a world of possibilities. The patterns we see are accidents of perspective, but they connect us to the generations who came before, who looked up at the same lights and wondered what they meant. The sky is both ancient and ever new, familiar and endlessly surprising. Telescopes have extended our vision beyond what the eye alone can see. They have revealed galaxies beyond the Milky Way, planets around other stars, the cosmic microwave background radiation left over from the Big Bang. They have shown us black holes, neutron stars, gravitational lenses, and the accelerating expansion of the universe. Each new instrument, each new observation, reveals more complexity, more structure, more questions waiting to be asked. The first telescopes, built 4 centuries ago, showed the moons of Jupiter and the phases of Venus. They revealed that the universe was larger and more complex than anyone had imagined. Since then, telescopes have grown enormously in size and sophistication. They now operate across the electromagnetic spectrum, from radio waves to gamma rays. They orbit in space, avoiding the distortion of Earth's atmosphere. They work together in arrays, combining their signals to achieve ever greater resolution. But you do not need a telescope to appreciate the night sky. On a clear, dark night, away from city lights, you can see thousands of stars with the naked eye. You can trace the Milky Way across the sky, a river of light that our ancestors also saw. You can watch meteors streak through the atmosphere, bright and brief. You can find the planets, wandering among the fixed stars, following their own paths around the sun. The naked eye sky is enough to inspire a lifetime of wonder. You can learn the constellations, trace the paths of the planets, watch the phases of the moon. You can see the Andromeda Galaxy as a faint smudge of light, the most distant object visible without optical aid. You can watch for meteor showers, counting streaks of light as bits of cosmic debris burn up in the atmosphere. The sky offers itself freely, asking only that you look up. The sky is always there waiting. It requires only darkness and clear weather and a willingness to look up. It asks nothing of you but attention. And in return, it offers perspective, a reminder of your place in something vast and ancient and ongoing. The stars do not know you are watching. They shine regardless. But the watching matters, if only to you, if only for a moment, if only as a way to feel connected to something larger than the concerns of the day. There is something healing about looking at the stars. The concerns that seem so pressing during the day shrink against the backdrop of the cosmos. The problems that consume our attention become smaller, not because they do not matter, but because they are part of something larger. The universe does not solve our problems, but it does put them in perspective. It reminds us that we are brief visitors in a vast and ancient story. Tonight, you are resting beneath that sky whether you can see it or not. The stars are there, above the roof, beyond the clouds, past the light pollution of cities. The Milky Way is turning, slowly as it has for billions of years. The sun is on the far side of the Earth, illuminating another hemisphere, but it too is orbiting the galaxy, carrying all its planets with it. Everything is in motion even as you lie still. The Earth rotates on its axis, completing one turn every 24 hours. This is what creates day and night, the familiar rhythm of light and darkness that has shaped life on this planet. At the same time, the Earth orbits the Sun, completing one circuit every year. This is what creates the seasons, the tilt of the Earth causing different hemispheres to receive more or less direct sunlight. And all of this, the daily rotation and the yearly orbit, happens as the Sun itself orbits the galaxy. Your stillness is relative. You are moving with the Earth as it rotates, nearly 1,000 miles per hour at the equator. You are moving with the Earth as it orbits the Sun, about 67,000 miles per hour. You are moving with the Sun as it orbits the galactic center, over 500,000 miles per hour. You are moving with the galaxy as it drifts through space, drawn by gravity toward distant clusters. Motion within motion within motion, and yet you feel only stillness. This nested motion is one of the beautiful truths of the universe. We are never truly still. We are always moving, carried along by the rotations and orbits of the objects we inhabit. And yet, because we share this motion with everything around us, we do not feel it. The ground seems solid. The air seems still. The stars seem fixed. Our bodies are not equipped to sense these vast, steady motions. We feel only changes in motion, accelerations and decelerations. The constant velocity of our cosmic journey is imperceptible. This is one of the quiet truths of the universe. We are always moving, but we do not feel it. We are always falling in orbit around the sun, but we do not sense the fall. Gravity holds us to the Earth, and the Earth holds its course around the sun, and the sun holds its course around the galaxy. Everything is balanced, everything is in motion, and yet from our perspective, the world seems still. The night seems peaceful. The stars seem fixed. Einstein showed us that there is no absolute stillness in the universe. Motion is always relative, defined only in relation to other objects. There is no cosmic frame of reference against which to measure absolute velocity. You are moving at 500,000 miles per hour relative to the galactic center, but you are perfectly still relative to the bed beneath you. Both statements are equally true. Motion depends on your point of view. The stars seem fixed, but they are not. They are moving just like everything else. Over thousands of years, their positions shift, their patterns change. The constellations that our ancestors knew will look different to our distant descendants. Some stars will fade as they exhaust their fuel. New stars will brighten as they form from collapsing clouds. The sky is not eternal. It is a moment, a long moment by human standards, but a moment nonetheless. The stars we see tonight are not the stars our ancestors saw, not exactly. The light is new, having left those stars years or centuries ago and only now arriving. And the stars themselves have moved slightly, shifted by their motion through the galaxy. The Big Dipper, for example, will slowly distort over the coming millennia, its handle bending, its bowl stretching. The constellations are temporary, like patterns in clouds, beautiful but impermanent. This is not something to mourn. It is simply the nature of things. Everything changes. Stars are born and die. Galaxies merge and evolve. The universe expands and cools. Change is not the opposite of beauty. It is the source of it. The Milky Way is beautiful not despite its impermanence but because of it. It is a structure in time, a pattern maintained by motion, a form that persists even as its components change. Impermanence is not a flaw. It is a feature. A universe without change would be a universe without time, without process, without becoming. The beauty of a sunset lies partly in its transience, in the knowledge that it will not last. The same is true of stars, of galaxies, of life itself. Everything is passing, and that passing gives everything its poignancy. We are not diminished by impermanence. We are made possible by it. You are part of that pattern. Your atoms were once scattered through the galaxy. They came together to form you, and one day they will scatter again, returning to the cycle of matter and energy that flows through the cosmos. This is not an ending. It is a continuation. The atoms that make up your body will become part of something else, perhaps a new star, a new planet, a new form of life. Nothing is lost. Everything is transformed. The matter in your body has been many things before it was you. It was part of stars, part of gas clouds, part of planets. It was scattered through space, gathered by gravity, processed by chemistry, organized by biology. After you, it will be many things again. It will cycle through the Earth's systems, be consumed by other organisms, eventually return to the soil, the water, the air. And in billions of years, when the sun expands and dies, it may be scattered into space again, to become part of some new cosmic structure. These are large thoughts for a quiet night. You do not need to hold on to them. You can let them drift like clouds across the sky, like stars across the centuries. They are offered not as burdens but as companions, ideas to rest beside as you settle into sleep. The universe is vast, but you are here, warm and safe, breathing gently, letting the day recede. You do not need to understand everything. You do not need to remember everything. You can simply rest, letting the ideas wash over you like waves on a shore, coming and going, leaving behind only a sense of vastness and peace. The galaxy will continue whether you think about it or not. The stars will shine whether you understand them or not. Your only task right now is to rest. The night is deep now, and the stars are shining even if you cannot see them. The Milky Way is turning, carrying with it hundreds of billions of stars, and among them our sun, and around our sun our Earth, and on our Earth you, resting, listening, drifting toward sleep. You are nested within these structures like a note within a chord, a breath within a rhythm, a moment within an endless unfolding. There is a kind of comfort in this nesting. You are not alone in the universe. You are embedded in it, supported by it, made of it. The galaxy holds you, not consciously but physically, through gravity and light and the slow cycling of matter. You belong here not because the universe was made for you but because you were made by it. You are its child, its expression, its way of knowing itself. There is nowhere you need to be. Nothing you need to do. The galaxy will continue without your attention. The stars will shine without your watching. You can rest now, letting the thoughts settle like dust after a long journey, letting the silence expand, letting the darkness become a blanket rather than a void. The darkness of night is not empty. It is full of stars you cannot see, galaxies too faint to detect, light that has not yet arrived. It is full of potential, of distance, of time. The darkness is not the absence of something. It is the presence of everything that lies beyond the reach of your eyes. When you close your eyes to sleep, you are not shutting out the universe. You are simply resting within it. The Milky Way holds mysteries we have not yet understood. Dark matter remains unexplained. The nature of dark energy is unknown. We do not know how common life is or whether we will ever detect it elsewhere. We do not know the ultimate fate of the universe. These questions wait, patient and unanswered, for future generations to explore. You do not need to solve them tonight. You only need to rest. The mysteries are part of the beauty. A universe we fully understood would be a universe with no more surprises, no more discoveries, no more wonder. The fact that dark matter remains unexplained means that there is still something fundamental to learn about the cosmos. The fact that we do not know whether life exists elsewhere means that the discovery, if it comes, will be transformative. The mysteries are not failures. They are invitations. The galaxy is old, but it is not finished. Stars are still forming in distant nebulae. Planets are still coalescing around young suns. The processes that shaped our solar system continue elsewhere, creating new worlds, new possibilities. The universe is not static. It is creative, generative, always becoming something it was not before. And within that becoming, there is room for everything, for stars and planets and life and thought and rest. Rest is itself a form of creativity. The body repairs itself during sleep. The mind processes the experiences of the day, consolidating memories, solving problems, making connections. Sleep is not passive. It is active, essential, productive in ways we do not fully understand. When you rest, you are participating in the same cycle of renewal that governs stars and galaxies. You are returning to a state of potential, preparing for whatever comes next. Rest is not separate from the cosmos. It is part of it. Everything rests sometimes. Stars rest between periods of activity. Gas clouds rest before collapsing into new stars. Even black holes, in some sense, rest in the centers of galaxies, waiting for matter to fall inward. Rest is a phase, a pause, a gathering of energy before the next unfolding. Your rest tonight is part of the same pattern, a small echo of cosmic rhythms. The universe operates in cycles. Stars are born, live, and die, their material recycled into new stars. Galaxies merge and evolve, their structures transformed over billions of years. The universe itself may cycle through phases of expansion and contraction, though we do not yet know. Within these vast cycles, your own cycles of waking and sleeping are tiny echoes, patterns within patterns, rhythms within rhythms. So let yourself sink deeper into comfort. Let your thoughts slow, your breathing deepen, your body grow heavy. The facts we have explored tonight are still there, waiting if you want to return to them, but they do not require your attention now. They are gifts offered freely, asking nothing in return. The thoughts can drift away like clouds. You do not need to hold them. They will be there if you want them later, in memory, in wonder, in the quiet moments when you look up at the sky. For now, let them go. Let everything go. Let yourself simply be, a warm presence in a vast cosmos, a brief awareness in an ancient story. The Milky Way is vast and beautiful and strange. It is made of fire and darkness, of matter and mystery, of time and motion. It is your home in the largest sense, the structure that contains your sun and your planet and everyone who has ever lived. And tonight it holds you gently as you drift towards sleep. You are held by gravity, the weakest of forces but the most far-reaching. The same force that keeps the Earth in orbit around the Sun, that keeps the Sun in orbit around the galaxy, keeps you gently pressed against the surface of your planet. Gravity is a kind of embrace, a cosmic holding that extends across the universe, connecting everything to everything else. You have traveled far tonight in thought if not in body. You have wandered among stars, considered the deaths of suns, contemplated the structure of the cosmos. Now the journey can end or pause or continue in dreams. The choice is not really a choice. Sleep will come when it comes, and when it does you will be ready. Dreams may carry you further than thoughts can go. In dreams you can visit other worlds, see impossible colors, experience the vastness of space in ways that waking minds cannot grasp. Dreams are not bound by physics or logic. They are free, creative, strange. Perhaps tonight you will dream of stars, of galaxies, of the great spiral of the Milky Way turning slowly through the darkness. Or perhaps you will dream of something else entirely, something uniquely your own. The stars are shining. The galaxy is turning. And you are here, safe and warm, part of something ancient and ongoing and beautiful. That is enough. That is more than enough. It is everything. You do not need to do anything else. You do not need to understand anything else. You can simply be resting in the vastness, held by gravity and darkness, breathing gently, letting go. The universe continues its slow and wondrous unfolding, and you are part of it, whether waking or sleeping, whether watching or dreaming. Sleep well. Dream softly. And know that the universe continues its slow and wondrous unfolding, whether you are watching or not, whether you are waking or sleeping, whether you remember these words or let them fade like starlight into dawn. The stars will be there when you wake. The galaxy will still be turning. And you will rise into another day, carrying within you the same atoms that have traveled through stars, the same matter that has been part of the cosmos since the beginning. You are never separate from the universe. You are always part of it, always home, always held. Good night.